Good morning, students. Today we will discuss the working or functionality of a control unit. How a control unit is designed. Okay. So we will discuss about the design structure of control unit and what is the property of control unit and how each circuit of control unit work and what are the types in which the ways in which a control unit can be designed. Okay, so first of all, what is a control unit is the question. So what is a control unit? It is the part of central processing unit. See, computer system consists of memory. There is a central processing unit. There are I/O devices, isn't it? So in the central processing unit, it consists of a control unit, arithmetic logical unit, and we have some memory register, isn't it? Do you remember? That was the first chapter in which we studied the components of a computer. Okay, so the central processing unit CPU consists of control unit, arithmetic logical unit ALU, and memory register. Okay, so this is broadly what we call a CPU. Now, what is the working of a control unit? See, control unit tells the computer or gives the signal to computer that what is to be done. Okay, which part, which circuit to activate in order to make the system run. Suppose we can see that this is the brain of a system. Likewise, as our brain works, suppose our brain gives a signal that the way we speak is determined by the signal given to us. Okay, suppose someone is attacking me, I lift my hand. Why? In self-defense, I have to lift my hand, isn't it? Because I need to protect myself. Now, this is an involuntary action. It happens on its own. Why? Because such signal is given to us. The body reacts accordingly. Similarly, the system works accordingly as per the signals given by control unit. So, how does the system functions? It is as per the signals given by control unit. Okay. So, what are these signals called? It is known as control signals. So, as per the control signals, the entire computer functions. Okay. Suppose the control signal is to activate ALU. Suppose the instruction is as such that we need ALU to perform it. Arithmetic, it is some kind of arithmetic, some modular function or multiplication or addition. For that matter, we need to activate ALU. It is decided by who? The control unit. The control unit sends signal as per the instructions requirement. Okay. I hope it is clear to you. Now, control unit can be designed in two ways. CU design can be done in two ways. One is hardwired and another one is microprogrammed. Okay, we say microprogrammed. Now, what is the basic difference between these two? In hardwired, it is purely through the hardware that the computer is functioning. Every processing is happening through a hardware. So, what are the hardware? Computer hardware, so you know, na? Registers, decoder, multiplexers. There are various circuit, adder circuit. In arithmetic and logical unit, we have adder circuit, we have multipliers, we have comparators, isn't it? So, you may have a subject called digital logic in which you will understand how a hardware functions, okay, through zeros and one, okay. So, hardware is focused on majorly hardware or the circuitry. The control signals activates the circuitry of or the hardware of the system, okay. In microprogram control unit, what happens is we write programs which is stored in memory. As per these microprograms are stored in a memory called control memory. In control memory, we can store microprograms microprogramming, it is more flexible. We can write microprogram, we can edit microprogram, we can add microprogram. Okay, it is more flexible rather than hardwired hardwired control unit design. Okay, so now we will see the structure, the actual design of the control unit in both these cases, in hardware and microprogram. The control unit design separately. Okay, so let's begin with hardware control unit design. So what happens is, the structure is as such. We have one control signal generator. Control signal generator. Okay, it generates control signals. Okay. Now these control signals are generated by what? Based on the instruction. Suppose it's an arithmetic instruction. Accordingly, control signals will be generated so that arithmetic and logical unit is activated. For example, so the generation of control signal is based on instruction. Okay, instruction code. So there is I1, there is I2, various instruction go into this control signal generator, and accordingly the control signal generator generates the control signal. Now this instruction is decoded from where? Instruction register. You know various kind of special register, isn't it? We have program counter which stores specifically the address of the next instruction. Similarly, instruction register stores the address of the instruction of the currently being executed instruction. Okay, it stores the currently being executed instruction. It doesn't store the address. I'm sorry. Instruction register stores the current instruction that is being executed. Okay. Now there are other factors involved as well, like conditional data, conditional signal, and ZDs. Now what are these? So there are various conditional signals. Suppose the register content of carry. If the carry bit is 0, then it will behave in some way. If the carry bit is 1, it will behave in some way. Okay. Now if 0th flag, that is we may have a flag that if the condition is 0, then it may behave in certain way. If the condition is 1, then it may behave in certain way. So these are conditional signal. Okay. So carry is one conditional signal, and Z is that is 0. If it is 0 or not. If 0 flag is set, then it may behave in some other way. Similarly, we have another conditional signal called overflow, that is denoted by V. If V is 1, then it will behave in certain way. So these are basically the conditional signals C, Z, V. Okay. So I am not writing this. This is not just for you to know. All you need to remember is there is some dependencies on the conditional signals. Now similarly, there may be some external input. So what is external input? External input means input from I/O. Suppose a key is need to be pressed. Okay, user input is required. Okay, so in such cases, this also affects the finally after taking inputs of all this, the control signal generator generates the control signal. There may be counter as well. Okay, Counter. So counter is also a combination sequential circuit, we say. It is a type of circuitry which you may study in digital logic. Okay. So counter according to the clock pulse. According to the clock pulse, it will count. In first clock cycle, something will happen. In second clock cycle, some specific operation will take place. Okay. So this way, the entire circuitry works in order to produce what? Control signals. So when the control signals are generated, accordingly, other thing takes place. Like the execution of actual instruction takes place. If it is an arithmetic logical instruction, then according to the control signal, the ALU will perform, or some other circuit may perform, adder will perform, subtractor will perform. Okay. So control signals basically guide the functioning or the processing of the instructions. Okay. So this is about hardwired control unit. Okay. Now, what is the second type of control unit? Microprogram control unit. In microprogram control unit, we have micro operation. Our instruction consists of micro operations, and each micro operation can be denoted as micro instruction or whatever you can call it. These micro instructions are stored in a special memory called control memory. Okay. So the memory is divided into words called control words, and we can store this instruction. We can, program this instruction. We can delete this instruction. We can edit these instructions. Okay. So as per requirement, we can, just like a normal program, we design the control programs. Okay. So control programs help us to generate the control signals. Okay. So let's see about the microprogram control unit. So what happens in microprogram control unit? We generate micro operations. Okay, the control signals is same as micro instruction. So what is control signals here? So control signal is equal to micro instruction or micro operation, whatever you can say. Now these are actually programmed. A microprogram, we call it microprogram, consists of too many micro instructions. Now all these micro instructions are stored in where? Control memory. So the control memory consists of, suppose this is a control memory, CM. Now this consists of a control word. It is divided into sections. Each section is called a control word. Okay, C1, control word. Our micro instruction is put in a control word. Okay, each control word consists of a micro instruction, or we can say micro operation. Okay, so now when to execute this, we have a micro program counter. The micro program counter decides which control word to refer or which micro instruction to execute. Okay. So, this is same as the PC program counter. In normal program counter stores what? The address of the next instruction. Similarly, microprogram counter stores the address of the next micro instruction to be executed. Okay. Now we have control data register, which stores the address of the currently being executed control word. Okay. So address of control word which is being operation, address of the micro operation which is being executed, and this, there are two sections, and this stores the address of next micro instruction. Address of next micro instruction. Okay. So this is about microprogram control unit. Okay. So it is very much more flexible than microprogram control unit. Why? Because here we can program the instruction. We can program the control signals. Okay. So control signals are nothing but micro instruction which we can program it. Okay. At the lowest level we can program it. We can store it. Generally memory instruction in which we do not know how much time it will take place. It is better to use microprogram control unit rather than hardware control unit. Because in case of hardware control unit, we should have fixed time intervals for it. We cannot take infinite time. So in cases where we do not know how much longer it may take to fetch the operands, then in such case we should use microprogram control unit. Okay. So this was about control unit design. Okay. So now furthermore, microprogram control unit is again divided into two types. What are the two types? Horizontal microprogramming, and then we have vertical microprogramming. Now, what is horizontal and what is vertical microprogramming? We discussed just now. See, in case of horizontal microprogramming, the control the micro instruction consists of two parts basically. One is the control signal and the next one is the next address. Isn't it? This is what we discussed. This is what the data control word consists of. Okay, control data register or control word consists of. Okay. Now this is actually a micro instruction. Now in horizontal microprogramming, what happens is, suppose this is our control signal. So in the control word, what is stored? Control signal or a microprogram, whatever, both are same, and next address, isn't it? Now in horizontal microprogramming, what it says is, if there are n number of control signals, we need n bit to represent it. If n number of control signals, that means n bits are required. So the size is n bit. So suppose this is one control signal, this is two control signal, coming to nth control signal. So how much size this required? This is n bits required. So we need n bit. Now, but in vertical what it says is, we need less space. Okay. So it is better. Why it's better? Because if we can store large data in less space, then it is more efficient. Okay. In terms of space complexity reduces. Okay. In horizontal microprogramming, what happens? Sorry, in vertical what happens? To represent n control signals, we need log 2 n bits. That means if there are 64 control signals, we need 6 bits. Now you may ask how, ma'am? Suppose this is 64 bits. In horizontal it means how much? We need 64. If there are 64 control signals, we need 64 64 bits. Okay. Suppose the bit is 0. Suppose we have the control signal 0, 0, 1, 0. 4 bits. We have 4 control signals. Okay, I am taking an example. How we can improvise this through vertical programming. 4 bits we have 0, 0, 1, 0. Now, this takes 4 control signal, 4 bit. This is horizontal microprogramming. Now, in case of vertical, what we can do is, this is what? This is 0, 0, 1, 0 is what? 3, isn't it? This is what? Sorry, 2. 0, 0, 1, 0 is what? 2. Isn't it? If we find the value of it, what is it? This is 2. Okay, 0, 0, 1, 0 is 2 in binary. So what we can represent it as 0, 1, 0. So we need just 2 bits. Here we needed 4 bits, here we need 2 bits. And what is 2? Log base to 4 is what? 2. Okay. Similarly, if the value is 1, 0, 0, 0, what is this? This is actually 8. Okay. Can we represent 8? To represent 8, we need how many bits? This is actually 8. Now in what position it is present? First position. So this is 0th position. So we can represent it as 0, 0. So 8 can be represented as 0, 0. Okay. Similarly, if it is present here, 0, 0, 0, 1. Now what is the binary value? 1. But where it is present? 0, 1, 2, 3, third position. So what is the value of in case of vertical microprogramming? It is 1, 1. Okay, you got it? So this is the index 0, 1, 2, 3. Whichever position 1 is present, you have to just, convert that in binary and represent it. That's the idea of vertical microprogramming. Okay. Suppose say the control signal generated is this. Now what is this? 0, 1, 2, 3, 4, 5, 6. The value of binary will be something, but this is 2. So we can represent it using how much bit? 0, 1. This is 1, 2, 3, 4, 5, 6, 7. So 7 are there, so we can represent this using 3 bits. Okay. Total in 3 bits we can represent this. So what is the value here? 2. The value will be 0, 0. So this is the value in 3 bits. Okay. So I hope it is clear to you. Even if you have any doubt, we can clear it in the doubt clearing class in Zoom. Otherwise, you can comment and post it in the comment section, or you can just call me or reach me via WhatsApp. Okay. So this was all about control unit design today. So basically, we studied about how control unit is designed. What are the two varieties? One is hardwired control unit, another one is microprogram. In hardwired control unit, the circuit generates the control signal and appropriately other functionality is being performed. In microprogram control unit, micro instruction acts as control signal. These micro instructions are stored in a memory called control memory, and accordingly we can generate new programs, we can create new programs, we can edit. So it is more flexible than hardwired control unit. Now, microprogram control unit are of again two types. One is horizontal microprogram, another one is vertical microprogramming. Vertical microprogramming is more space efficient. Okay, to generate n signal we need only log n bits. But in case of horizontal microprogramming, to generate n control signals we need to represent it using n bits. Okay.